So today we are going to talk about ultra low latency So think 5G, think 5G specific solutions, and leading that pack is Industry 4.0. I've got only 30 minutes of time to talk to you today, so we're not going to do deep dives on anything. I know you're all going to be really disappointed. Nothing I love to talk about than really low-level tech, but we're going to keep it high level. If you have any questions, jump over into the virtual booth. I will be in and out, and I'll primarily be manning it. So I'd love to chat with people and answer any questions that anyone has. Otherwise, we're going to start with a look at the last year. We're going to take a look at what Industry 4.0 is and the special use cases around it. And we're going to talk about some of the exciting new solutions and benchmarks that we've been doing here with Aerospike at HPE and the Full Stack Data Science Lab. And then we're going to end with some work that HPE has done around COVID-19 and how Aerospike actually was involved in that. And then we're going to also talk about how this entire presentation rolls right into next year's work. So last year, we developed a lot of really amazing solutions around Aerospike. And at HPE Discover in June, I hosted what I call cabana meetings. They're very relaxing. It's a very intimate setting for just a select number of strategic accounts, and it's my way to thank them for all kinds of phenomenal teamwork and collaboration. And we had a guest of honor show up, which was our Edgeline 8000. And you probably can't see it in this picture, but it's sitting in between the meat and cheese tray and the fruit tray. And it was phenomenal. So we've really focused a lot of solutions around edge specifically, and leveraging the Edgeline platform. The Cabana meeting, it generated a positive ROI for scale for Aerospike and for HPE within just a few months. It was incredible. One of the accounts that we're proudest of working together over this past year has been for a leading digital payments provider. Aerospike beat out HBase, and in a POC against several other NoSQL databases, it outperformed everybody. The hardware included HPE ProLiant DL360 NVMe servers with persistent memory. Again, PMEM really hit the market fast and furious this time last year, and we wasted no time in building out really fine-tuned high velocity solutions for specifically these types of accounts. And so it was really great to see this customer take advantage of some of those initial designs that we put together. So just some quick stats. It reduced this client's database cluster node count by as much as 2/3, and it accommodated triple the data set size, and they're still able, well, I shouldn't say still, they are now able to meet their 99.99% uptime SLA, and they accommodate a payment processing window of 10 to 20 milliseconds. And these bottom two variables were what they were really struggling to meet before. So now let's jump into the work that we've done here in FY20, which is around Gen 4 Industrial Revolution. And these use cases are very different. However, they all pretty much use the same pipeline. So the Full Stack Data Science Lab in Fort Collins, we specialize in open source. And we do that for a reason, because commercial software, Aerospike included, is not cheap. So you have to use it very wisely. Industry V4 use cases are very high velocity and phenomenal amount of data. They satisfy typically 3, 4, maybe all 5 of the big data volume, velocity, veracity, value, all those variables come into play with Industry 4.0. So for that reason, I use Aerospike on the front end. Pretty much Aerospike everywhere when it comes to Industry 4.0. This ensures I have 0 data loss. and it also actually creates a very economical footprint when I leverage a lot of the connectors as well as the internal tools that Aerospike has built into it. As far as downstream applications go, you see that I have MapR here. This could also be open source Hadoop. We have Vertica in play here for the near real-time machine learning aspect, simply because it's fast. Most people who are using Aerospike are simultaneously also using Vertica. So it just made a lot of sense to combine the solutions for those customers wherever possible. And we use S3 throughout the entire designs for flexibility. So by building the solution around an S3 compliant architecture, it doesn't matter where the customer has their data at. Everything is built using a full microservice cloud scale implementation, so they can move data wherever it needs to go. So keeping that in mind, some of these use cases include a desperate need for real-time weather forecasting with Industry 4.0. So weather sources, a lot of people don't realize, many of them still provide daily email updates. They're coming in PDFs. Very few of these sources actually offer real-time or near real-time updates. So this is something that needs to seriously be looked at and rectified. And the reason that this is so important is because renewable energy has it's all over the world right now. Everybody is looking to go green as quickly as they possibly can, conserve resources. And so we're building more and more renewable energy footprints, which include wind farms onshore and offshore, as well as solar. And these renewable energy sources, they serve a great deal of demand. And as a result, it is incredibly important to be able to accurately predict weather events such that the energy market can make accurate predictions. These traders need to be the first to act, and that's very hard to do when you're dealing with weather updates that are not accurate. We also have emerging use cases around commercial drones. So commercial drones are huge. The FAA just expects this to climb and climb and climb, the number of commercial use cases that are out there. There's tremendous benefits to using drones in commercial operations. And they also are cheap. They're relatively cheap for the most part. So for about 20 grand, you can implement a very, very highly sophisticated drone program with one, maybe two drones, and the ability to perform photogrammetry and other LiDAR specific use cases such that you can accurately present 3D visualizations. These generate a lot of data points, millions upon millions of data points. So the tool that you are using to collect all this data becomes incredibly important. So when we talk about drones, some of the fastest use cases to be presented out of that are inspection use cases. Anybody who has the ability to capitalize on an inspection use case, they're looking to use drones for that. And if you think about bridges, I love these photos, and the photo with the workers in it, it really touches a special place in my heart because my father was a bridge builder. So he worked at the top of the tallest bridges, and you don't really appreciate how risky that job is until you actually see a photo like this. And when you think about just a basic bridge inspection, it can take as long as 4 hours for the bridge inspectors to do, and you always have to have a minimum of 2 for safety reasons. A drone can do this work in an hour. So it not only has the ability to recoup these costs annually, but it is saving lives is how I like to think of it. Railroads is another big one. Drones have the ability to perform basic rail inspections, and so we have we're taking people out of these risky situations. Whenever you put people on the same tracks as trains, which are using these tracks as scheduled daily, you put a human being into a precarious situation. So drones mitigate this risk because they fly over the train. So Wind turbine blade inspections is another use case for drones, and it's one that's getting more and more attention. And this, again, it has primarily to do with safety. So workers currently have to climb up these ladders in order to visually inspect these blades a lot of times, if a camera from the ground cannot do it. And so drones have the ability to significantly cut the time for these inspections, as well as the human inspection costs. So again, it's another area where we can keep human beings safe by offloading these type of inspections to technology. So now let's talk about what makes Industry v4 use cases so difficult and why you specifically need a tool like Aerospike to accommodate them. So this is your typical layer cake design, and I often refer to this as the trash can slide, because executives love these slides. They pretty much have everything, including the kitchen sink, tossed into the slide, and very few people realize all the effort, all the legwork, everything that actually occurs in the background to make something like this happen. So in the Full Stack Data Science Lab in Fort Collins, we build this, and we sustain it, and we build it based on use cases. So this is something that I hold very near and dear to my heart, and I'm very critical of people who present me this slide, because I expect them to know what all the individual arrows mean, what applications are in there, what are those flows, what is happening. So since I was instructed to keep this meeting high level, I didn't go into that level of detail. So what you need to know is that everything here has the ability to run anywhere. It can run on a private cloud, it can run in a public cloud, and it can run on-prem, on bare metal. It doesn't matter. We use one design for everything. And what's important is the middle layer. So the Semantic Web, which provides your holistic view of all your devices. So on the left, you have your traditional motors and gears, everything that requires traditional gateways in order to be able to suck the data out of. And then on the right, we have all of our smart technology. So everything that is internet connected, Wi-Fi enabled, and we're able to bypass those gateway bottlenecks. You're never really going to get away entirely from the gateways, at least I would say for decades to come, simply because there's too much proprietary technology out there that has yet to be ported. There's just not enough skills in order to move all that technology as fast as we would like to see it move. So in that case, you have to focus on how do you meld all this data in that middle layer, that web layer. How do you meld all that data together, get it into a cleansed format such that you can run it through an analytics pipeline? This is a real-time machine learning pipeline. And you're basically ingesting real event streams. You're performing on-the-fly data mining in order to pull out just the data that you want. So you're giving structured to unstructured data. You then run your machine learning algorithms against it, and you can feed it through your models at that point. And only then are you able to derive some sort of intelligence out of that data that you can then serve the application at the top level of our layer stack here. So it could be decision making. It could very well be visualizations and dashboarding. Augmented reality is a new area that is really taking the world by storm. And or perhaps chat and web ops, or NLP, natural language processing, Q&A, and information retrieval systems. So the Semantic Web is very different from columnar databases, something like your traditional relational and non-relational database, Aerospike, for example, which is a NoSQL database. Semantic Web uses, it's called triples, which basically means we have two entities and we illustrate a relationship between them. So in this example here, on the right, we have an employer name, we have an employee name, and then we have the relationship that connects that employer name to the employee name. And it's very simple, but it allows for tremendous scale. scale like nothing else can currently accommodate. And so these network of triples, as they are known, are more generally referred to as graphs or graph databases. And so we have to use these for semantic web technology, and specifically Industry 4.0 is going to use GraphDB because it is very fast, it's highly flexible. We're moving towards more and more quantum machine learning pipeline driven use cases, such as logistics and routing, and current technology does not have the ability to answer these, what we'll refer to as the traveling salesman problems in a reasonable amount of time. So the world is really looking to quantum machine learning techniques in order to accelerate, not necessarily solve, because this really traveling salesman is not a quantum use case, but it would definitely accelerate the logistics and the routing type problems that are out there. And so the question then is, how does this pertain to Aerospike exactly? Well, as Industry 4.0 stores all this high velocity data into their NoSQL databases, you have to be able to transfer or to extract this data out of your NoSQL database and into a graph technology. That giant red arrow there, you're going to start seeing this on more and more executive slides within the next year, I promise you. It doesn't exist. So that's the missing link to this puzzle, is we have graph databases out there, and we have a phenomenal NoSQL database industry. And but what we don't have is we don't have the tools that exist, at least in the open source space, the space that I care the most about, to be able to take columnar values like we would see in Aerospike or NoSQL databases and transition them into a graph model, which is what you would see on the right. And so this is really what I've been focusing on with Industry 4.0 use cases in my lab, the full stack data science lab. So some of the new work that we have done around Aerospike over this past year, again, everything I do, it revolves around an AI-driven pipeline, an AI use case. So Aerospike is one piece of that puzzle. Aerospike is going to be running on very fast servers, whether it's our Edgeline EL8000 hardware, it could be ProLiant DL360s, DL380s, persistent memory configurations, doesn't matter. It doesn't matter to me where Aerospike is. It could be sitting in the cloud for all I care. However, to be able to do anything meaningful with the data that I have currently sitting in that primary source of truth, that Aerospike database, I have to be able to inject it into my memory-driven machine learning pipeline. And that's what you see at the top of this slide here. So I currently have what I refer to as my big distributed data set. And it uses all open source tools. There's no commercial products in this pipeline. And it allows it to scale very, very well, and it's highly performant at scale. And there is not one drop of this pipeline that touches disk unless I choose to write results out to disk at some point later. But all the processing occurs in RAM. And so what we do is we get all the data into a universal format whenever we can. And the universal format that I try to use is Parquet. And the first thing you're going to say is, well, Aerospike doesn't support Parquet. Well, that's okay, because Aerospike has a Python plugin. And so I have the ability to connect into the Aerospike database using my Python API to pull out the keys and values that I need in order to enrich my data set. And so I'm not going to spend a lot of time on this. I just wanted to show you basically how Aerospike fit into my deep learning as well as my machine learning work that occurs for every single one of these use cases. Not just Industry 4.0, but autonomous and energy and weather and astrophysics, and the list goes on from there. So the work was actually not performed by myself. There's actually a team of 4 people, and it included Keith from ScaleFlex, Tibor from Aerospike, and then Denise and Trevor from the Full Stack Data Science Lab in Fort Collins. And so these 4 people, they worked around the clock, basically, working to complete these solutions so that I could include this data in this presentation. All of this work is going to be part of a larger solutions brief and a solutions RA, but I wanted to present the highlights. And Tibor just wrapped up his final performance benchmarks last night. So my sincere thanks to this team. They're unbelievable. So the very first piece of work that we did was around Aerospike's latest version, which is 4.9, which has the integrated HPE PMEM, and which is, it features Intel's Optane persistent memory DIMMs. So we had a lot of clients in this test, and I'm not going to go through it because I have right around 9 minutes left in my presentation time slot. But again, this will be fleshed out at a very low level in the solution RA for anybody who wants to repeat it. But what you need to know is we had 3 Aerospike servers in this cluster, and they were all running persistent memory DIMMs. So Aerospike was configured for all indexes and all data to be stored in PMEM. Now, we ran this test last year, and I couldn't believe that Aerospike actually let me run it because it was completely unsupported. And so for me as a developer, that said a lot about the confidence that this company had in the product that they build. The results of this unsupported test just blew my socks off. 8 million transactions per second approximate. And that was incredible. Now this is a read-only test, so we did do writes, we did a mixed workload, but I just grabbed the highest transactions per second for this slide here. I wanted to make an impact. So this year, Tibor ran the exact same benchmark test as last year, exact same. He changed nothing except the code, and we were able to get 14.87 transactions per second. 14.87 million transactions per second, I'm sorry. And Tibor indicated he likely could have got close to 18 if he had more clients. So it was absolutely unbelievable. Now, I'm sure a lot of people are out there saying, yeah, that is impressive, but seriously, who really needs performance like that? Well, the customers that I develop for absolutely do. And just some interesting data here is we have more and more accounts in industry as well as academia who have massive supercomputers that are looking to feed these systems with real-time pipeline data. And just to give you an example of NOAA's brand new supercompute implementation, which is using the 2 HP Crace systems. So this image that you see here is of one system, one supercomputer. They're going to have 2 of these on the floor. They're massive, and it's going to be able to handle approximately 40 petaflops. So 40 petaflops, it's nothing in the grand scale of exaflop technology. So when you think about exaflops, those are the type of quantum machine learning pipelines that the next level of industry and academia is looking to in order to achieve the real-time events that they have to have in order to satisfy timely and highly accurate data. So I see Aerospike at the forefront of being able to truly build out some of these real-time pipelines such that we're able to support the continuous data feeds that these supercomputers would like to eventually see. So then we talk about ScaleFlex, and ScaleFlex was the second benchmark that we did in the lab this year, and it was some pretty impressive technology. I've been working with the ScaleFlex team for the past year, and what they have is they have a pretty impressive computational storage drive. There's all kinds of benefits of the technology that they have, but the one that I was very specifically interested in seeing was compression offload, because a lot of my accounts, they want to compress data, but they can't afford the CPU overhead. It costs too much to compress data. They lose too much CPU to it. So that was the test that I cared the most about. That was the one that we really focused on. And what we found was really quite amazing. And so just a little background on what ScaleFlex is and how exactly we did this test. So ScaleFlex is it is a computational drive. It's an all-in-one turnkey solution. It's hardware, it's software, it's firmware. It provides enterprise updates, and while it is basically an FPGA, there's no knowledge or coding required. They do all the work. You plug it in just like a drive, and then you if you're using Aerospike, in my situation here, it just works. So now compare this to a traditional SSD. All the components are in different locations. So multiple components are required in order to support the compute and the SSD functions with your traditional NVMe SSD drives. And ScaleFlex integrates all of that onto a single chip, a single card. So the test that we did, the observations were impressive. So ScaleFlex observed a 3x improvement in CPU utilization over the NVMe SSDs. And this allowed us to achieve twice as much throughput. So we could achieve higher operations per second to the ScaleFlex drive than we could the NVMe drives, the SSDs. And we also saw an 80% reduction in latency by using the ScaleFlex drives versus the NVMe drives. So this was a really interesting test. Again, we'll do a solution RA around this, and it will have all the details highly refined in this, but it answered the questions that I needed to know for the next gen architectures, the next gen designs, which more and more we're going to see this type of computational offload because it's cheaper than constantly scaling your server workloads, your storage workloads. And there's just a lot of really amazing stats from this ScaleFlex benchmark work that was done. So for instance, the average NVMe SSD drive, the queue size would peak at around 15, and ScaleFlex, it was able to handle over 160 threads before latency started to incur. Absolutely amazing when you're dealing with a product like Aerospike, which has the ability to sustain many millions of transactions per second. And so something that was equally interesting was the difference between writes and reads with ScaleFlex. So the level of writes that we had was around 400,000 when it was a write-only workload, and a little over twice as much with a read-only workload. And in talking to Tabor about this, we thought that it was likely due to the additional overhead that was required from replication. And so all the Aerospike data is replicated across the cluster. So there's actually a lot more than just a single write that's occurring to ScaleFlex when you have replication enabled. So that's an area we definitely want to do more investigating into to see if we can actually improve the write workloads. So now that's pretty much it for the work that we've done over the past year around Aerospike development and the Full Stack Data Science Lab in Fort Collins, Colorado. What I want to turn the attention to now is the White House's call to action for the global data science community that occurred on March 16th. With that, my lab was pretty much shut down for day-to-day operations, and we converted everything to COVID work. And when Allen AI, the Allen AI Institute, their Semantic Scholar team, they released the COVID-19 data set. this is a bunch of research articles, tens of thousands of research articles actually, that they have compiled into a machine readable format. So what we did with that is we did some pretty phenomenal. We built an architecture in order to ingest all the data from all the COVID data that we could get our hands on, as well as epidemiology data and just a bunch of different data sets. And we married all that into a real-time pipeline. And then we are building a custom dictionary that has the ability to continually learn as more articles are published. And so that's definitely one area that we were able to give back to this this global pandemic on. And then another area is the donations. So Aerospike, Intel, and HPE are donating a portion of all the conference attendees to 2 different relief efforts for COVID-19, which is phenomenal. And then this is the actual pipeline that was developed for this real-time COVID-19 discovery that we did in Fort Collins. And you'll see it's using a lot of the same tools. It's pretty much using all the same tools that you've seen already in this slide. And we pretty much ingested all kinds of different data sources, anything that was applicable to COVID-19, infectious diseases, this topic at hand. We injected all that raw data into a pre-processing pipeline built around NiFi, Kafka, and Flink. And we ran it through a cleanser. I just refer to it as a data cleanser. So dirty data went in, it got transformed, it comes out clean data. Keys and values were dropped into Aerospike, and then everything else that would be more relevant to my NLP pipeline went into an on-prem S3 cloud. And this could have just as easily been Hadoop, an HDFS connected system, but I already have the pipeline built up from the work that I was doing before my lab was pulled into COVID-19. It was all set up for S3 work. So this was the fastest path to development for me at the time. And then we ingested everything into a memory-driven machine learning pipeline. From there. So all the data that was cleaned, we pulled it into Python, and that's where we did our NLP model development for our information retrieval system, and for our it was basically a hybrid QA system. Vertica, which is super easy to do a lot of machine learning with, was used to basically clean up the data, do visualizations, help me figure out what data is really going to accelerate the movement of this development as quickly as possible. With Vertica, I can execute these machine learning commands in basically a single step, maybe 2, whereas Python, it might take me 6 to 8 to 10. So I really value tools when they can accelerate my work. And then we did all the visualizations with open source again. So I used RStudio, which has phenomenal visualizations tools, and so this is some of the work that we've done. This is eventually going to be rolled into a proposed testbed for work next year, which will be for research and development for a sequence alignment step, offloading this computational workload from CPUs or GPUs, and everything that you saw in this presentation, from Aerospike to ScaleFlex to persistent memory, will all be used in that Superdome Flex solution development. So from that, we really hope to be able to further help and further benefit the pharma community. So with genomics acceleration and molecular dynamics simulation acceleration. And with that, that is it. So I will be in the virtual booth for the duration of the conference, in and out, and please stop over and say hi. Otherwise, thank you again, and enjoy the event.